Good evening, everyone. I hope you are learning, understanding well, and enjoying the course. So, in this today's live session, we will be taking up your doubts. You please keep on posting your doubts into the chat box. In the meantime, there are very few questions in the discussion forum that also we will take until we have more questions in the chat box. Whatever your doubts in the previous sessions, previous lectures, please post in the chat box. We will answer those one by one. In the meantime, I have with me Nandlan, who is the TA for this course, and he will be telling what are the questions being posted in the discussion forum.
The first question is what are the potential research areas in the field of green hydrogen production for upcoming researches?
Okay. So the question is about green hydrogen production, the possible research areas. If we specifically talk about hydrogen production through electrolysis, then we already know that currently the cost involved in the manufacturing of electrolyzer is high. So alkaline electrolyzer, we have already discussed that comparison of cost and all. So the issues with, let's say, PEM, which has a higher outlet pressure, is the cost of materials which we are using. These cost of materials include the membrane cost as well as the electrocatalyst. So the requirement in terms of research is how to bring down the cost because of the components which is membrane and catalyst. So usually these are the platinum group materials which are used as catalyst, which we need to replace it by non-platinum group or less expensive catalyst. Similarly, membrane, we know that it is Nephron membrane, which is there by DuPont. And then we need to also see what could be the other possible alternative membranes. In terms of electrolysis, when it comes to electrolysis, then the possible other areas could be a sort of economic analysis, how as the cost goes down with economies of scale. So techno-economic analysis, the cost, how it will come down, that could be studied. Besides, if we talk about the other methods of hydrogen production, whether it is using sunlight, so light generated charge carriers, which result into your splitting of water. In that case, the efficiencies are poor as of now, and then scalability is a problem. So the possible research area there could be how you can improve onto the efficiency, what could be the new materials which could lead to such improvement, and how that technology could be further scaled up so that you can have large area such electrochemical cells. So these are some of the possible areas. Other than that, this is in terms of the electrolytic cell. But then there are a lot of other challenges when it comes to balance of plant. The manufacturing in terms of what are the other components which are including the rectifier, which is a major component. So there are other aspects which are into the electrical aspects which needs to be considered when it has to be integrated with grid. In that case, the interfacing of these or with the renewable energy power plant, how the integration will be impacted, what are the challenges on that aspect. So these are some of the key research areas which you can look at and work on if you are interested in.
So another question is for storage of hydrogen and activated carbon, which kinds of pore space is required, and what should be the do's and don'ts when we think of storing hydrogen and activated carbon?
So when it is in general, let us say about any of the materials which store hydrogen by means of adsorption. We have seen that the process is by means of van der Waals bonding, or it is an adsorption based process wherein a weak bond is formed. So that means the process is basically governed by your temperature. That is, it should be low temperature. So what you require is a low temperature or a higher pressure. So in that case, this is the do. Like you require that, and you have to increase the surface area in whatever material you are using. So you have to have a higher surface area. You have to increase the porosity. At the same time, the consistency is very important in these materials, because sometimes it has been observed that materials have been synthesized. At one time, you may get a certain value of the storage capacity, but when you repeat that in another batch, if you repeat, the same repeatability is not observed. So there are certain things that needs to be addressed. That needs is that how you can increase the temperature so that you can have close to ambient conditions absorption in such materials, and also how you can scale these materials further. Like the problem lies with MOFs, that the scalability is an issue. So in general, on a high surface area materials, surface area plays a very dominant role. So at present, I could see no questions in the chat box. Please post your doubts here. Okay, so Hemant has posted to check the options provided for question in assignment 9. So what were the options?
The options are correct.
Maybe Nandlal, he is here because. So the options provided are, can you come on this side and maybe you can respond?
Actually, there are two equations which we provided. One is like in the lecture,
You can
there's
speak.
del H by RT and minus del S by R. And the another form of equation which we use is minus del H by RT plus del S by R. So whatever we have provided in the option is correct. Only thing is the query is in lecture, both this equation exist. So they are saying, since you have written primarily in the slide this equation, they say that this is the correct form, this is not the correct form.
This is how you plot it. That depends upon.
Yeah.
So actually, if you write the entire equation, then whatever answer is being provided for that particular question is correct. But however, if you take that negative sign onto the left hand side, then it changes. But the correct option is given in the in that particular question in the assignment. So that is, there is no problem with the answer in that question.
The next question is by Soman. He's asking, there's a news in 1 year ago that large amount of white hydrogen has been found in France. How to tackle this competition efficiently by India?
So this white hydrogen is still under a lot of discussion, because it is being found, and then, like any other gas found underground, lot of excavation and then infrastructure as well as cost goes into it. So the requirement is to see what, when such resources are found, in that case, what you have to see is how you can efficiently and cost effectively use that resource. Now, depending upon how much is the quantity, whether putting in whether the economics will work well or not, that has to be identified. So that is the primary thing that needs to be looked at. Because if you are setting up the entire infrastructure, which will be highly capital intensive, and the amount of hydrogen which you are going to dig out is less, in that case, the economics does not work well. However, there is a lot of discussion which is going on. You have to identify the potential of that particular area wherein white hydrogen is being discovered. So that is also being considered as an option, and a lot of debate is going on about it.
The next question is by Jinesha. Does making composite with other carbon nanotubes and carbon-based nanostructure improves the storage so that we can go for ambient temperature and pressure storage? This is related to our activated carbon storage.
Yes. So making composite is helpful. There is a lot of research which is going on. Maybe if you can write down personally on our email address, then either Nandlal or me can forward you some of those papers. So a lot of work is going on in terms of carbon-based materials, wherein it is shown that they can improve the storage capacity. Anyway, they have very good storage capacity. Only since these are at lower temperature, the requirement is to bring the temperature up to the ambient temperature. So a lot of work is going on. Yes.
So next question
Okay.
is, how do we calculate gravimetric density experimentally?
Actually, we have already covered this in one of the lecture, gravimetric density, how we have to calculate. So if you remember, I do not exactly remember the lecture number, but therein we have talked about how to measure the capacity using Sievert apparatus. We have also mentioned there are two methods, like maybe that by that way you will be able to identify well which lecture I am talking about. So it is measurement of volumetric based and the gravimetric based methods has been described there, wherein we have talked about Sievert apparatus. In that particular apparatus, in a known volume, if we use the pressure equation, that how much amount of pressure difference arises, in that case, in case of absorption or desorption, then that amount can be mapped with the number of moles of hydrogen which is taken up or released. So that equation and all we have described in one of the lecture. So there is an apparatus which is standard equipment which is known as Sievert apparatus. Please go to that lecture and then you will be able to understand how that is being measured.
Someone is asking, is there any expected location in other parts other than France as a white hydrogen where we can found white hydrogen?
It's like it cannot be an expected location because once it is being explored, then only you can come to know. So even there are discussions in our country, but then until and unless you have a signature of existence or substantial amount of existence of this hydrogen, you may not be able to go ahead. So there won't be a green signal until and unless, as I mentioned, the reserves are of large quantity of hydrogen. So you have to identify first.
Uh, There's a question by Hridesh. How feasible is it to blend hydrogen into existing natural gas pipeline used in CGD network?
I think this has been already talked about by Professor Sandeep in the last class, last live session. Yes, it is feasible. Uh, so we have also discussed in the lecture that volume percent, it is feasible. Definitely the answer is yes. But what percentage, that depends upon uh, what is your end use appliance, for what you are going to use it. To what extent, what is your infrastructure which can support that amount percentage of blending, as well as where you are going to use that, whether that particular appliance, end use appliance, is capable of meeting that requirement or managing that requirement. So all that depends upon that. So feasibility is definitely yes.
Sri Krishnan, I have a question for NPTEL exam. Do we have a graphical questions further for the questions related to electrochemical cells and materials related to storage? Should we learn all the equations and material types?
Graphical question, no. So the questions will be all MCQ. Values, if required, will be given, but the general understanding will be like the equations you need to remember. And these are very basic equations, I think. Yeah. But the values and all which are required, like the general abbreviations and constant values, will be given. Yes, any other question? Please keep posting in the chat box. So MCQs will be from assignment as well as not from assignment, but from the course content, whatever is being delivered.
Ratio of numerical and theory question. This
It's
cannot be.
it's not well defined that you have to give this many. So it is not a well defined, but yeah, both will be there. Theory as well as numerical problems will be there.
Yeah, this I think is following up on the question, like I think blending for vehicle and supply to domestic or commercial or industrial customer, the blending context.
Yeah, so see, if it is, as I mentioned, that what appliance can handle, that is decided, that will decide the blending percent. Uh, like if you say for domestic, so at present, like blending level is 18%, which is already being, it's like feasible and being considered.
How advances like how can blockchain technology help in HPTS? Not sure. High pressure.
Can you
Give the
please
full form
elaborate?
of.
Yeah. What? So this question is not clear. Advances blockchain technology help in HPTSU. Can you please expand that HPTSU?
The other question is, can we extract hydrogen from active volcanoes, like seawater put into active volcano to rise the temperature and keep them in hydrogen tank below the deep sea?
This seems to be a very difficult option. I have not even thought about it. Would be innovative, but little difficult to actually execute.
Some notification mail regarding NPTEL audio questions for September 2025 exams received in my mailbox. Is such form of questions will be there in the final exam? No.
No, no audio questions will be there. This may be for other courses, but not for this particular course.
Sri Krishna is having a question. Is metal hydride storage under operational for commercial applications?
Yeah, so there are many demonstrations there for vehicles like forklift. It has been for post office vehicle. I think some of the examples I would have given in that. And then there are demonstration for submarines as well. So there are many operational examples wherein metal hydride have been used for both vehicular as well as the domestic application. In some of the countries, there have been certain buildings wherein which are powered with hydrogen. Then the storage has been demonstrated with metal hydride form as well. So both for vehicles as well as for stationary application, there have been demonstration wherein storage of hydrogen has been in metal hydride form.
So that blockchain technology question. So is
Hydrogen
it
production transport.
hydrogen?
Oh,
It's a complete value chain.
in advances, how can
Blockchain technology be applicable?
I need to.
So there, I mean, this AI, ML, and this context is coming into this kind of hydrogen value chain.
Correct. So actually, there are, if I give you certain examples, is there are certain hydrogen valleys which have been announced in India. So there are 5 hydrogen valleys which have been announced, wherein they are looking at production, storage, transport, utilization. Therein, lot of AI ML will be integrated to not only manage but to understand. There will be digital twins that will be adopted. So definitely these will be adopted in all these aspects of the hydrogen energy value chain. And with the coming time, we have to see how beneficial this will be. But these are definitely useful. The tools, AI, ML tools will be useful in understanding it better, maybe improving in terms of the processes as well.
Uh, so, Somin, you can write to ma'am, mail to ma'am. If it is something to be looked upon, ma'am will definitely reply.
Yeah.
Appreciate your efforts into this.
Please post your questions, doubts in chat box.
Recently, draft rules for storage and applications of green hydrogen was shared by SO, Government of India. If metal hydride storage comes commercially, which government agency will be responsible for the license?
See, again, the thing is that if it is meant for which application. So if it is the PESO is definitely there because it is dealing with the pressurized vessels, although the pressure in the metal hydride tank is not very high, but still PESO will be the governing body. But at the same time, if it is in automotive sector, then AI will also contribute towards these the responsible for the rules, draft rules. So both PESO and ARAI will be involved in that.
So they're having a question, how can hydrogen be handled below minus 30 degrees Celsius? Which material can be used for storage?
Minus 30 degrees Celsius. So we are already, Sandhya, because we have already talked about minus 253 degrees centigrade. So handling hydrogen at minus 30 degrees centigrade is not a problem. Because even other gases also, even your liquid nitrogen, it is 77 Kelvin. So there are materials used, cryostats, you have thermostats that are already being in use. So this is not a problem handling at minus 30 degrees centigrade. The thing is that what you require is a very good insulation. You can have multi-layer tanks and then insulation in between. Minus 30 degrees centigrade is not a problem. We even talked about minus 253 degrees centigrade.
Question is, what is the challenge India is facing for commercialization? IOCL Research and Development in Faridabad is exploring, but why so much delay in commercialization?
This is related to so commercialization of
For green hydrogen.
okay. So commercialization, see, if you see there is a strong push from all the dimensions. It is IOCL definitely has been working since last several decades, in fact, their R&D unit, and they were the first to have the hydrogen refueling station in the country. And their R&D unit has also been doing pretty well since last several years. There is, so see, currently, if you see the major driving force is the incentives which are now coming up and the engagements, global engagements, because we are all identifying the challenges of the climate change and decarbonization. We are all together for decarbonization. But the major bottleneck that is coming up is the cost of hydrogen which is being produced, as well as the cost of green hydrogen, because your electrolyzers are at present capital intensive, although with time the cost has reduced. So the problem is at present the cost which is involved. And commercialization, if you see, there are say various support mechanisms that government has announced, not only in India but abroad as well. Lot of incentives are announced, and these are going to increase the scales. So it is not that commercialization has not happened. There are electrolyzers, several electrolyzers. Now, if you see, there are so many startups which are into into the business into green hydrogen. They are coming up with the electrolyzer manufacturing, and it is not only in India but as well as globally that this trend has been seen. So with time, we expect that we will have better learning, as well as the economies of scale will bring down the cost, and then we will see more proliferation of these technologies.
So the next question is in terms of alkaline electrolyzer. So in making alkaline electrolyzer while using aluminium, copper, and SS, which will be the best for as electrode material if we are generating hydrogen? And follow up on that is what concentration of KOH is optimal for hydrogen production?
Exactly, I am not able to remember.
So one question is related to electrode material for alkaline electrolyzer, and another is for having like concentration of KOH.
See, these are very, at present, if you see, the alkaline is very standardized. So modifications, because everything is it's a major technology, everything is well defined. There is research going on to increase onto the performance and the pressure which you can obtain. Exactly, I don't remember what is the KOH concentration. I think you have to check into one of the lectures. At present, I'm not getting that number. So there are various possibilities of improving onto the efficiencies and performance. All that is the topic of research. What will further enhance the performance of these electrolyzers? But alkaline is more or less stabilized. Everything is streamlined and things are very pretty much, because this is the technology which is on large scale production side, and large units are available commercially since a long time. I think engines we will cover in the next discussion, your live session, when Professor Sandeep is there. He is an expert into the CNG engines, and we will talk about it in the next live session.
So there's a question: is solar water splitting the greenest hydrogen production possible?
Actually, greenest, it is green hydrogen production process. How we compare greenest, it is difficult because nobody has compared as of now. When you talk about greenest, that means you have to start from cradle to grave. So that means even the emissions you have to consider by when your solar panels are. So this is a typical study that I think I would. I hope you would be you can start doing that work as well. But it is not a comparison. It is like green hydrogen. Greenest or not, that is, you have to see which technology you are comparing with. And also you have to see emissions altogether. Even manufacturing, if you see of these components, if you count that also, then you have to do a lot of work before claiming that, okay, this one is the greenest one, hydrogen production. Anyway, this is the green hydrogen production.
There is a question: what are the equipments to separate hydrogen from air from our surrounding?
Okay, this is some of the recent finding that we have seen in news. I think you have read about it. I didn't.
So, I mean, there is some sort of a electrolyzer route only, but prior to electrolysis, there is some more process involved. So, it's a recent finding. I think if I can answer it in a discussion forum.
Okay, so this thing is very recent, and this was in news few days back only. In which country?
China.
China. So there was a finding which has been reported that you can extract hydrogen uh, from air surroundings. So we have to see that how they have reported that. You can write in the discussion forum, and we will go through the recent finding, and then we will answer accordingly.
There's a question from Weber. What is the thermal efficiency of electrolyzer and fuel cell?
Thermal efficiency. Okay. Usually the numbers are, because if you say 60% of the efficiency, that means the remaining is going in terms of losses. So usually we count here in terms of fuel cell or electrolyzer is the electrical efficiency. So whatever is the energy you are taking in, and so how much is the energy output compared to whatever is the energy input, and we count in terms of electrical energy. Because it is very difficult to say, because there are several losses which are involved. Primarily it goes also as a form of heat as well. So a very quick answer could be like whatever is the remaining losses could go in form of heat as well.
Is transport of hydrogen a challenge in India? Is it safe to transport hydrogen in cascading cascaded cylinders like natural gas?
So it is not a challenge because this system is there. So we have, like, if you see, there are different companies which are already being the leaders globally, and they are present in the country as well. So if you see whether it is liquid hydrogen transport or gaseous hydrogen transport, it can be done safely because all these, so maybe the next coming few weeks will be about the safety aspect, and we will also talk about, I think the cascading has not been considered till now. So till this week, so the next coming 2 weeks will be about hydrogen transport. Maybe you will be able to understand that better once you see those, once those sessions are live. Next 2 weeks are live. It is not a problem. It is currently also being done. So transport in term, there are companies like Liquid Hydrogen. If you see Air Products, Lind, they are well known. Praxair. There are many companies which are there, which have been transporting. Their cascades are there. Their trucks are there for transport of hydrogen.
Next question is, the solar being used as an energy source, doesn't it comes under yellow hydrogen?
Grid. Ma'am, with solar, does not it come under?
Yellow hydrogen.
Okay, so it is with grid or without, so that depends. So yes, we need to check. It is with grid, I think. So there are different ways. In fact, solar also, whether it is with, we will respond to you. Let me check that. So if it is electrolyzer getting electricity from grid, I think then it is called.
Okay. Electricity from the grid.
Yeah.
Power.
So what was your question? Yes, it is solar.
It is a green.
No, but solar, if it is renewable, then it is green. What you are asking is solar coming under yellow hydrogen. No, because yellow hydrogen is when you are getting that electricity from grid, which could be a thermal power plant. The most energy to use as a fuel when compared to other gases.
As a fuel when compared to other gases.
Because of its energy content in itself, that the calorific value of it is very high. So you can extract more amount of energy when you burn it on combustion. Every renewable energy comes under green category. Yes, correct. No, I think the context is different. We have a color coding. So yellow star is okay. This is something different, but it is, see, the color which has been assigned to hydrogen, it is on the basis of from which source it is being produced. So whether it is being produced from natural gas, or whether it is produced from renewables, or whether it is produced from coal or from methane, according to that color, it is not the color of hydrogen, it is not the color of the resource, it is the color which is being on the basis to map the production route and from where what is the raw material used for producing, or what is the resource which is being used for producing hydrogen. According to that, a color code has been assigned. So Greek solar, any renewable, yes, green color is assigned to the hydrogen being produced from it.
Please keep posting your doubts. With the transport of hydrogen in the form of an ammonia has explored. So which is safer, hydrogen or hydrogen in the form of ammonia?
So yes, definitely it is a very hot topic, burning topic. In fact, use of transporting hydrogen in the form of energy dense materials. Ammonia is one of the potential candidate wherein a lot of work is going on, and even in the form of ammonia, the transport becomes easier because we are well aware with that infrastructure of transporting hydrogen, transporting ammonia, and we have been using ammonia for quite some time. We know what are the safety features, what are the mechanisms that are involved. So hydrogen transport as ammonia is one of the choice when it comes to safely transporting hydrogen. And a lot of work is going on. Many countries are leading in that particular method of transporting hydrogen. There are ports which are developed now these days, which will be transporting hydrogen in the form of ammonia. So a lot of work is going on globally. Even in India, there are ports are being developed, bunkering facilities are being developed. So one of the method in which hydrogen will be transported is ammonia.
Is it true that hydrogen can be used in space exploration? Or not?
Yes, it has been used. Somen, hydrogen has been used very, I think it is the first and foremost use has been like it's widely being used for space exploration because it is an energy dense fuel. So it is used for space exploration.
Can we extract hydrogen from hydrocarbon? Will that be complicated due to strong bonds between a carbon and hydrogen? And this was discussed in steam reforming from the hydrogen.
Actually, this is the whole part. We have one, I think, three lectures, beginning lectures on hydrogen production, wherein how we can extract hydrogen from hydrocarbons is discussed. There are so many methods of getting hydrogen from hydrocarbons, whether it is methane, so steam methane reforming or partial oxidation, autothermal reforming, dry reforming, bi-tri reforming, all those have been discussed in the previous lectures. This starts from the very first week. I think I would suggest that you please go through that part. You will get all your answers. Yes, definitely it can be produced from hydrocarbons, and those lectures are dedicated to hydrogen production from hydrocarbons.
If electrolyzers are costly, why nuclear plants develop not used for commercial applications? India is rich in thorium. Why this is not explored in India?
I think this is one stream versus another stream. So it won't be correct to compare this because see, there won't be a single solution in any of the energy domain. You cannot say that, okay, only solar is going to work or only wind is going to work. There will be multiple solutions. And one of this option is hydrogen. Hydrogen is, again, it is not a resource but it is used at various places in industries. It can be used in transport or domestic application. So again, it is an energy carrier, but the flexibility it provides is, which is even better. We can say it can be used in variety of applications, wherein it is not only heating purpose, it can also be used for electricity, producing electricity, power generation. So there are multiple uses. Now you cannot compare solar with nuclear or wind with nuclear. All they have their own advantages and disadvantages. We all know that. So comparing hydrogen with nuclear is not a correct choice. However, we can say that hydrogen can be produced through nuclear with the help of nuclear reactor, because whatever is the waste heat which is available in nuclear reactor, that can assist in reducing the requirement of electrical energy for producing hydrogen.
This question can be taken next. Like excessive humidity of byproduct of hydrogen combustion cause breathing problem for humans.
It won't be the case, like breathing problem, but the excessive amount of humidity byproduct of hydrogen combustion engines, that won't be the case. If you see the Mumbai climatic condition, already we have how much humidity we have in Mumbai or the coastal regions. So that won't be the case. But still, about the humidity levels, what will be the outlet uh, amount of water vapor and all, we can discuss when it will be in the next live session when Professor Sandeep will be there, where he will talk about the engines. Yeah, any other question, please post onto the chat box.
What should be the next level of learning after completing this course? As of now, specifically in India, there are a few companies which are actually into green hydrogen or any other sort of hydrogen.
Next level of learning, that depends upon at present, Hemant, I am not sure like what you are doing, whether you are a student or whether you are a faculty or you are working in an industry, because there are a lot of open-ended problems still there with the hydrogen ecosystem, whether it is at every part of the hydrogen energy value chain, whether production. So there are a lot of challenges still which needs to be addressed. There are a lot of research which is required. I'm not understanding like where, because I can help you out with what type of learning you want in which particular stream, which particular area. If you, as a student, you are asking, the things will be different. If as a researcher, you are asking, it will be different. And if in an industry you are working and then you are asking, then the things will be different. If you can mention what particular thing you want to hear from me, then I will be able to better answer your question.
There was a question, we can explore thorium as an electrolyzer using DFT simulations. Only the base material is the question.
Actually, when you say any nuclear waste, then the technology that is the heat exchange which is being considered. So the high grade heat which is available from the nuclear reactor, that can be used for producing hydrogen, because if you remember, we started the lecture on water splitting with that if you want to split water, the energy requirement for splitting water is very high. That's why we started with the various thermochemical processes and then finally ended up with talking about the electrolyzers. So there is an energy requirement. Now that energy requirement can either be met through thermal energy or thermal and electrical energy in a hybrid manner, or it can be entirely electrical energy. So herein, when you say thorium, that means you are again trying to focus onto the nuclear reactor. Then in that case, there is a technology wherein you can use that waste heat. So these are high temperature gas cooled reactors wherein there is a heat exchange mechanism, and that required temperature is supplied, which helps in reducing the energy requirement for water splitting. So that is actually the way in which it works. DFT simulations are, in fact, usually these are micro scales which are these done. However, there, if you see in these high temperature gas cooled reactor, a lot of heat exchange, the losses involved, you have to do a sort of analysis wherein heat transfer is involved, the heat exchangers are involved. So the studies will be targeted more towards it.
The question is there any firefighting system developed to extinguish or control hydrogen fire? What technology has been developed to detect hydrogen fires as it's invisible?
Yeah, so see, extinguishing fire is you have to stop the oxidant so as to curtail the combustion process, and you have to bring it out of the flammability limit. So that is the way in which now how you can do that. There are multiple ways of doing detecting hydrogen fires. So as there are itself flame is invisible, but let us say if in that surroundings there are certain materials which are kept, let's say if it is a table or a chair, then that wood or plastic or something else, rubber, that will burn, that will show as a flame. So itself it is invisible, but if there is any other species present, then it will start showing the combustible products in the combustion products in the environment. Now if let us say nothing is there, in that case, the temperature variations through thermal imaging, you can see that, okay, there is a change in the temperature, a high temperature presence can be detected so as to identify such flames.
The next question is, apart from civet apparatus, what can be used for characterization of developed material for hydrogen storage capacity assessment? What are
Gravimetric.
the existing equipments?
So Sievert apparatus is completely based on the volumetric method. There is gravimetric method also which is available. Gravimetric method like you have, but these are based on highly sensitive microbalances wherein any small change in the weight is being measured so as to map it with the amount of hydrogen which has been taken up. So that is with the capacity of the material holding hydrogen. There are other methods wherein if you can also do desorption studies can also be done through your TGA, the TPD. These are the other temperature. So I think these all we have discussed. Temperature program desorption studies can be done. If in fact in TGA mass spec you can even see how much quantities of hydrogen or hydrogen is signature of hydrogen which is being released.
Next question is, do you have any PDF or material safe practices for hydrogen storage utilization and transport for lab scale practice and also commercial separately? Can you share?
See, there are very nicely defined protocols which exist for safe usage of hydrogen. Uh, you write to us, we will share with you, because many times what happens is there are SOPs, but there are sometimes unusual situations also, which you come to know as and when you practice into those environments. But yes, there are protocols and safety standards. There are clearly defined manuals how to operate with. So please write to us. We will send you some of the links wherein you can access those.
So there is a next question by Somi. Is there any new advanced process to produce hydrogen more advanced than white hydrogen?
New advanced method. So advanced, if you say, then how to tell in terms of advances like photoelectrochemical are the recent ones, wherein light is shined and catalyst is used so as to split water. And as we have recently heard about the white hydrogen, so this is a new method wherein you can think about like whether it is feasible or not. So these are some of the new something which is new, which has been heard in recently. Like now the recent one was from air, they have extracted hydrogen. So these are some of the recent advancements.
So in the context of the next level learning, so Hemant is saying I'm working as a mechanical engineer in oil and gas downstream engineering. So whether I can try to switch in hydrogen sector as a mechanical engineer after this course.
This course is a fundamental course, but definitely because a lot of systems design, you can be really a very much like your knowledge could be very much useful. And for designing certain systems, so if you see at each and every part of it, there is a system optimization and design which is important. Uh, let's say if I talk about my area, which is metal hydrides, we have also discussed about how the system or the reactor design, how the heat exchange plays a dominant role, what type of heat exchanger we can select, what could be the geometrical parameter optimization. So there is a lot of work which mechanical engineers can do. Each and every part of the aspect of the hydrogen energy value chain. However, this particular course, because it was everything, this was a fundamental course wherein we covered all the aspects. So this definitely provides a basic understanding, but more and more advanced understanding comes with either researching in that area, or maybe we will also maybe in future try to float more courses in this particular area wherein we cover either, let for me it will be storage will be convenient.
Oh, please keep posting your doubts, and if there is no more doubt, then we'll look towards ending the sessions almost.
Yeah, if you have any doubt, please keep posting into the chat box, else we will soon wind up with the session. So Hemant, because you have been into oil and gas PSU, so there are many things which are in common, and like we have already discussed that the raw material feedstock itself, hydrocarbons based hydrogen production has been primarily used as of now. Then when we talk about natural gas, then storage, underground hydrogen storage, these are some of the topics wherein you can your experience will be helpful. So all those systems which are there for underground hydrogen storage, it is one of the topic again on large, when it is large scale long term storage comes into picture. Even the solid state storage we talked about, compressors, the the compressor is one of the key part in the entire value chain of hydrogen. This is again wherein you are a mechanical engineer and contribute into that area. Transportation, because all these cascades and all are at higher pressure, the hydrogen refueling stations. So your experience is very much crucial, and you can even work in any of these aspects in the hydrogen sector.
So there is a next question: how to check the life cycle of any storage device? What factors to be considered, and also the cyclicability of the tanks for the storage?
I think your question is targeted towards the metal hydride based tanks. Life cycle is whatever is the process. Like let us say if I give an example of the metal hydride, then one cycle means you absorb hydrogen into it, the material whatever it is, and desorb out of it. So the same process which you have used for measuring the capacity during charging or discharging or the other parameters, you repeat that large number of times. Usually it is like 1500 cycles the testing of such materials is done. So whatever absorption or desorption process, you have to repeat that the same process for 1500 cycles. So that is what is the cyclability. And then you have to see what is life cycle, like at the end of it, what is the capacity which is left out? Can you regain that? Or it is becoming dead, then how much, after how many cycles it is not absorbing anymore? That you have to see.
Uh,
Okay.
with current geopolitical solution, is hydrogen a solution or challenge to India?
With current geopolitical situation, definitely hydrogen is a solution. Because in that case, there are, as we have seen, there are multiple options from which you can produce hydrogen. Uh, in fact, there are a lot of startups and companies which are coming up for electrolyzer manufacturing. It can be produced from whatever source you say. So whatever is the, as in the very first lecture I mentioned, whatever is the locally available method, feedstock technology you can use for producing hydrogen. So that can be definitely beneficial. So you may not depend upon the imports for using hydrogen for an energy carrier, in fact.
So does hydrogen create blistering in underground tanks over a long time?
It's not tank, in fact, because these are the geological structures, or you make a lining of that. usually the interaction is more with respect to metals when it comes to metals. However, there are studies, a lot of studies, because this is a very important topic when it comes to underground hydrogen storage. The thing is that there is no clear cut, because every geological structure has a different, in fact, in general, let me say morphology, because the porosity may be different. If it is an aquifer, what is the cap rock? The composition of those rocks will be different. The material you are feeding in fact, it is different. And none of the sites will be completely similar. So there are a lot of challenges there. However, blistering is blistering is observed when the rate of absorption desorption is not, it's actually very fast. But when we talk about these underground storages, it is a constant rate, and it is the less chances of blistering are there. However, this is very site specific problem, and a lot of research is required before coming to any conclusion, and a lot of research is already being done, and still many things needs to be actually studied before we can make a concrete statement about it. Thank you, Suhashini. Okay, so I think we will wind up with this session, but you please keep posting your doubts in the discussion forum and we will respond to those. There were certain specific questions wherein you have asked about certain resources, certain links. We will post that. Please please drop email and then we will respond to it. Hope you will have again the next coming weeks also, you will enjoy those lectures and will have great learning experience. We will meet again in the next live session. You collect your doubts till then. Thank you for joining this live session. Bye.